So, good day everyone. Now we will discuss the program 2 of laboratory activity number 9. And this is a program that will display a table of trigonometric functions, sine x, cosine x, and tangent x, for x is from 0 to 20 degrees. So, now we'll proceed to the analysis of the codes. First one is the include IO stream, which we have discussed from the previous activities already, which is a really important code, as well as using namespace STD, because with these two codes, our computer will be able to read the program. Without them, there is no program, or there will be no output that will be given to us. So your codes will be nonsense without them. Next is the include CMAP, which is a really important code for we are using a mathematical operation which includes trigonometric functions. Next is the hashtag include IO manip, which is for the code C out, fix, set precision is the 4. We have included this, our group have included this because we wanted our output to only have 4 decimal places as seen in the instruction. Next is the hashtag define pi as 3.14, which is really important and really essential for the computation for trigonometric functions later on. Now we will proceed to the int main. We put bracket, then we put int x is equals to 0, which basically means that the the degrees will start with 0. Next, see out angle in degrees, sine x, cosine x, tangent x. The slash t and slash n are for the spacing, so it will be clean when the output will come out. Next is the do statement, bracket. Um, Here we can see the float, which is a really important code that we use so that the answer will come out with a decimals decimals in short, because without it it will only be a whole number. So the first one is float radians, and radians here is what we will use for the trigonometric function. This will serve as the angle. So the formula for it is x times pi over 180, where x is the degrees, which is 0 to 20, times pi, which we have defined here, and over 180. And here we will use it for computing the trigonometric function sine x, which is sine times radians. Next, cosine x, cosine times radians. Then lastly, tangent x, which is tan times radians. So the C out here, x, then slash t for spacing, sine x, cosine x, then tangent x. Here we have x plus plus, which means x plus 1. For example, 0 plus 1. But we also put here while, where x is less than or equal to 20. So this basically means that the program will only include 0 to 20 degrees. Degrees that are greater than 20, for example, 21 will not be included in the output. Then lastly, return 0, then bracket. So now we will go ahead and run the program. So this is the program. output. As you can see, the angle in degrees is 0 to 20. And these are the values of the sine x, then the cosine x, and then the tangent x. So for the analysis of program 2 lab activity 9, dual loops are useful type of loop statement in C++ programming. They allow a block of code to be executed repeatedly based on condition, with the added benefit that the code inside the loop is executed at least once, regardless of the condition. This makes them particularly useful in situations where you want to ensure that a certain block of code is executed at least once. And for the conclusion, while dual loops are less commonly used than other types of loops such as for loops and while loops, they still have a place in certain programming tasks. As with any programming concept, it is important to understand that the strengths and weaknesses of do-while loops and use them appropriately based on the specific task at hand. That would be all. Thank you.